So for an organic reaction to take place, there are certain steps which it follows before it forms the product. Okay, so you just here you have a way, like suppose you have reacting species. Whenever this reacting species is also called as substrate, okay, is reacted with some reactive agents, okay, like attacking reagents. At the beginning you have reactants or substrate. Whenever some reagents are put into it, then what will happen? Some making and breaking of the bond takes place. Now as a result of that, what will happen is we get some intermediate. And this intermediate now will convert into product. Now from the intermediate, some byproducts can be eliminated, and finally after elimination of the byproduct from the intermediate, we get the product. So this is a sequence of reactions for a substrate to be converted into product. So what is mechanism then? Mechanism is nothing but the path or the sequence of reactions or the path it follows before converting into product is known as what? Reaction mechanism. So on page number 12.62 you have the definition for this reaction mechanism. The sequence of steps through which a reaction is supposed to take place is called reaction mechanism. So the pathway for a reactant to be converted into product, whatever path it follows, is simply known as what? Reaction mechanism. So in organic chemistry, you have two reaction mechanism mainly. One is concerted, the other one is non-concerted reaction mechanism. The first one is concerted, the other one is non-concerted reaction mechanism. Types, okay. The first one is concerted mechanism. In concerted mechanism, what happens is you have potential energy on the y-axis, and this side you have reaction coordinate. So progress of the reaction is this side. Progress of reaction on the x-axis. So now any reactant will have such an amount of energy. So this is the energy of the reactant. So it possesses this much of energy. Now before being converted into product, what will happen? It has to cross certain energy barrier. Okay? Now, here in this case, you can see this is the amount of energy required. Now this amount of energy is known as what? Activation energy. This is activation energy. Now in this case, in case of concerted mechanism, what happens is making and breaking of the bond takes place simultaneously. Okay? What happens in concerted mechanism? The making of the bond as well as making of the new bond and the breaking of the old bonds take place at the same time. Therefore, it is known as what? Concerted mechanism. And it has only this state is known as what? Transition state. Okay? This is known as transition state. So in the book you have the definition. Reaction mechanism in which the making and breaking of the bonds takes place simultaneously without the formation of any intermediate. Here you don't get any intermediate. You are getting this the transition state. Okay? So this is your concerted pathway or concerted mechanism of an organic reaction. So let's discuss about the other type of reaction mechanism, that is non non-concerted mechanism. Now, non-concerted mechanisms are those reactions in which the formation of intermediate takes place. That means here making of the bond and breaking of the bond does not take place at the same time. Okay? So this side you have potential energy on the y-axis and here reaction coordinate. That means progress of the reaction. Now, in this case, what happens is here you have this reactant has to cross certain energy barrier, then it has goes to lower energy. Then again, here again it has to attain some energy to be converted into product. Product is here, reactant is here. Now it has certain energy here and here two energy levels. Now this state, which is lower than this, the energy required for making and breaking a bond is known as what? Intermediate. Okay? So intermediate is stable. Now after this, again it has to gain certain energy to cross over to the product side. So, okay, here we have two transition states. This is first transition state, the first one, and this is the second transition state. Hope you understood. Concerted, no intermediate is formed, whereas in non-concerted, we have intermediate, and here we have two transition states. Now, let me tell you the difference between intermediate and transition state. What is transition state? Transition state is a state, okay, in the mechanism of reaction in which you will not be able to isolate what is the product in between formed. So transition state, it is not we cannot isolate it, we cannot get it. Whereas in case of intermediate, this intermediate can be isolated. We can separate it from the reaction and we can observe what the intermediate is. Okay, so the main difference between transition state and intermediate is what? Intermediate can be isolated, whereas transition state cannot be isolated. So these are the points that you have to remember from this particular section of types of reaction mechanism. Now let's move on to electron displacement in organic compound. So you have the topic is given as what? Electron displacements in organic compound. Now this portion is very, very important. Okay, there are certain effects. We are going to learn about certain effects and how are they going to control the reaction. Now if you learn about these four effects properly, if you understand it, then you will be able to do the mechanism of the reaction of most of the organic reactions. So please, you have to listen to it very carefully. So let's begin the discussion of different types of effects that governs the reaction. So in organic chemistry, you know, in organic chemistry, the bond between these compounds are mostly covalent bond, and in this covalent bond, okay, whether you have electron going away from the carbon atom or whether the electron is coming towards the carbon atom, displaced towards the carbon atom. Now these are the things that are going to control the reaction and to which carbon atom does the reaction take place. So if you understand this one, then it will be very, very easy. So let's discuss about inductive effect first. So the first one is inductive effect. Inductive effect. It is also denoted by I. Okay? So inductive effect is a permanent displacement of electron towards certain atom in a compound. Okay, so on page number 12.63, refer to page number 12.63, we have inductive effect. So here they have given the definition of inductive effect. The permanent displacement of the shared electron pair in a carbon chain towards the more electronegative group is called as what? Inductive effect. So here, if I have to give an example, suppose you have CX. And what will happen? This bond formed is what? This bond formed is covalent bond. Let's take this for example. Now in this case, it is carbon and halogen. Here you have carbon and carbon. Now the electronegative difference between carbon and carbon is what? 0. Therefore, the shared pair of electrons will be situated exactly at the center, at the midpoint of this two carbon. Whereas in this case, what will happen is, since halogen is more electronegative than carbon, then here the shared pair of electrons will be shifted towards this halogen side. Yes or no? Now, this permanent shift, here there is no shift, no inductive effect, but in this case, we can see that this shared pair of electron is always shifted towards the halogen side. Then such permanent shift of shared pair of electron, okay, towards the more electronegative atom is known as what? Inductive effect. Hope this is clear. Now let's discuss the type of inductive effect. Now inductive effect are of two types. It's very easy to remember. Plus inductive effect, plus inductive effect, and the other one is minus inductive effect. Now, in case of plus inductive effect, suppose you have some alkyl group CH3, say CH3, now CH3, and say you have hydrogen. Now in this case, this carbon center, please look at this carbon center. Okay, look at this carbon center. In this carbon center, we can see that this carbon center has three alkyl groups: methyl group, this methyl group, and this methyl group. Now, methyl group, they have the capacity to shift its electron towards this carbon. Okay, these alkyl groups are shifting its electron towards this carbon center, and in the process, this carbon is being enriched in negative charge. That means electron. The density over this carbon will be enhanced because of this CH3 groups. So alkyl groups which enhances the electron density over the nearby attached carbon are said to be showing what? Plus inductive effect. So this is an example of plus inductive effect. So how many plus inductive effect is here? 1, 2, 3. So here we have plus 1 I effect, plus I, and plus I effect. So 3 plus I effects are present here. Now in case of minus inductive effect, now whenever you have halogens atom, okay, attached to carbon, that means if any element is more electronegative than carbon, then they always tend to take away the electron from the carbon center, then they are said to be showing what? Minus inductive effect. Suppose you have, say, carbon, you have, say, chlorine here, chlorine, say, hydrogen, and hydrogen. Now in this case, what can we say? We can see that this chlorine is taking the electron from this carbon center away from the carbon center. This chlorine is also taking the electron away from carbon center. That means the electron density over this carbon is being decreased. Now, this effect, which decreases the carbon density and which decreases the electron density over this carbon, is known as what? They are said to be showing minus inductive effect. So, how many minus inductive I effect is it? 1 and 1. That means 2 minus I effects are present in this particular compound. Okay. Now on page number 12.64, you have a sequence of the order of negative inductive effect and also the order of positive inductive effect. So both of this series you have to learn it properly. Okay. Now from here, inductive effect, its series and application of inductive effect is very important. Okay. So application of inductive effect we are going to discuss now. Application of inductive effect. Now, there are so many applications of inductive effect. Now, out of this, the first one is reactivity of alkyl halide. So, the first one that we are going to discuss is reactivity of alkyl halide. Reactivity of alkyl halide. So here, let's take this example: CS2, CS3, CS2, and say halogen. Br is present. Now, for this reaction to take place, suppose you have KOH, substitution reaction. This is aqueous KOH. Now, this is positive, this is negative. Now, for this reaction to take place, what will happen? This has to be substituted with this link profile. Okay. So, in the first step, what takes place is breaking of this bond. Since the electrons are present this time, so you will be having CS2, CS3, CS3, and you will be having a positive charge. Now this is known as carbocation, and this negative part will be staying as Br minus. Okay, and in the second step, this OH will be attached to this, and the reaction takes place. But here we are concerned about reactivity of alkyl halide, and for this purpose we have to look at the stability of the carbocation. What we have to look? We have to look at the stability of the carbocation. More the stability of the carbocation, that particular compound will be reacting faster. Please remember this. More the stability of this particular carbocation, the faster will be the reaction. Now in this case, you can see that this carbon is having, the central carbon is having positive charge. Now, here what can you see? You can see that you have CS3 group, CS3, CS3, 3 CS3 group. Now this 3 CS3 group will be showing plus I effect, plus I effect, plus I effect. And what is plus I effect? They are shifting this zero pair of electron towards this central carbon, That means now the electron density over this carbon will increase, and before you can see that it is already having the positive charge. That means it is deficient in electron, and those deficiency of electron is being fulfilled by this plus I effect. Now what do we think? If positive charge is there, now if negative charge will be coming nearer to it, means what? They will be more stable. So you have to remember here, more the plus I effect for carbocation, more will be its stability. So let me write, more the plus I effect in our carbocation, more will be the stability and hence the reaction will be faster. The reaction will be faster. So just we have to see it this way. If there is carbocation, more is the number of plus I effect, more will be the stability of the carbocation, okay, and faster will be the reaction. So this is clear. Now here, how many plus I effect you have? You have plus I effect. How many? 3 of them. And see this compound. This bromine is attached to this carbon. Now listen carefully. This bromine is attached to this carbon. Now this carbon in turn is attached to 3 different carbon. 3 different carbon. Therefore, this third degree alkyl halide. This is third degree or tertiary. We can also write tertiary. This is tertiary alkyl halide. Okay. Similarly, if you have this compound, say CH3, and you have hydrogen, and here you have Beta. Now in this case also, you will be getting carbon CH3, H, and here carbon. This bond has broken. Now here you can see how many alkyl groups are present. 2 alkyl groups, 2 plus I effect. Here how many plus I effect? 2 plus I effect. And this is also stable, but compared to this, here how many? Plus 3 I effect. Plus 3 I effects were there. But here you have only plus 2 plus I effect. Now you know which one will be more stable? Obviously, the one which is having 3 plus I effect will be more stable. Therefore, the reaction rate of this third degree tertiary alkyl halide will be faster. This, can you tell me this degree alkyl halide is this one? Since this carbon, see this bromine is attached to this carbon in turn is attached to how many carbons? 2 carbons only. The other one is hydrogen. This is therefore second degree or secondary alkyl halide. So this is third degree, this is second degree. First degree will be the alkyl halide which is attached to only 1 carbon. So you know what are now third degree, second degree, and first degree.